Welcome back to C# for total noobs on developer ramp up. In this lesson we'll talk about boxing, unboxing and type conversions. And I really hope that you're still holding up. This is already the 13th lesson and we're still talking about classes or topics that are in some way related to classes. This is to emphasize how important classes are in today's programming. If you remember correctly, during the last lesson we talked about value types and reference types, and we have seen that classes are reference types while structs, like for instance integers, are value types. And I won't go in this distinction once again here. This time we need to go one step further and we'll talk, as said, about boxing, unboxing and type conversions. Before we dive really in, I have to say that at least boxing and unboxing as topics are, in my opinion, not that important for C# developers, especially not at the beginning stage of one's journey to become a software developer. The reason is that it's true in C# and in .NET there is a lot of boxing and unboxing going on behind the scenes, but we as developers, we do not use daily these boxing and unboxing concepts. Type conversions, however, are more important, and you will encounter scenarios in which you will have to perform time conversions fairly often. So let's get started right now. When talking about boxing in C#, this means, or this is the process of converting a value type to the type object, which is a reference type. So we could even say that the boxing process, or yes, the boxing process converts a value type into a reference type, and we wouldn't be that wrong at all. Now, boxing a value type also allocates an object instance on the heap and copies the value into the new object. And if you remember correctly, we discussed during the previous lesson how value types are allocated on the stack and how reference types are allocated on the heap. So we said that a value type should normally be on the stack while reference types should normally be on the heap. And this means that when we box a certain value type, it means that we need to create also a reference type for it on the heap, in this case an object, and to allocate the specific value to that object on the heap. And here is also a graphical representation of this process. So at the beginning we have this integer I, which equals 1, 2, 3. Then we go through the process of boxing this integer into an object. As said, object is a reference type. And what happens when we do the boxing process is, well, as you can see from the arrow, that a new memory allocation is created on the heap, so a new object is created on the heap, and the integer value 1, 2, 3 is then stored there. So what this basically does, it removes this integer value 1, 2, 3 from the stack and it puts it on the heap inside an object, which is a reference type. It is also possible to perform the boxing explicit, but explicit boxing is almost never used. That's why I've said that there is a lot of boxing and unboxing going on behind the scenes in C#, but we as developers really do not work with these concepts every day. Still, it's very important because almost always when you attend interviews for a software development role, especially on a junior position, there are often questions about boxing and unboxing, so it's important to know about these concepts. Now, we have seen what boxing is. Of course, unboxing is very similar. It's the reverse process. So unboxing is an explicit conversion from the type object to a value type. This occurs in two different steps. The first one is to check if the object instance and to make sure that it is a boxed value of the given value type. What this actually means is that we can only unbox reference types or unbox objects that were basically previously boxed. So if we have an object that doesn't have a previously boxed value, then we are really not able to unbox it. And then the second step is, of course, to copy that value from the instance on the heap, so from that specific object, to the value type variable, which will be right now once again on the stack. And in fact, if we look at this graphical representation, we see this exact information. So in the first part of the picture is what we discussed 2 slides earlier, when we had this integer value 1 to 3 that we really boxed into an object and moved it to the heap. And in that case, well, we had right now some more space on the stack. Then we want a new variable j, and j should be equal to the boxed value. So in this case, you see here in this picture, we use this parentheses and int inside of them, and then of course o, which means that okay, please take the object o, take the value from it, and assign it as an integer to j. Now, since this value 1 to 3 was previously boxed, as we have seen earlier, it is possible for us to perform this type of explicit unboxing. Now, for the unboxing of value types to succeed at runtime, the item being unboxed must be a reference to an object that was previously created by boxing an instance of that value type. So it's exactly the process that we discussed about earlier. If you try to unbox objects that were not previously boxed, then you could have some errors. And if you attempt, for instance, to unbox a null object, then this causes, of course, a null reference exception. But if you attempt to unbox a reference to an incompatible value type, then this causes an invalid cast exception. What this means actually is when we try to unbox a value from an object that was not previously boxed. In that case, we will get this invalid cast exception. Let's go now to the third topic for this lesson, which is really very important, more important than boxing and unboxing, because we encounter this really often. And this is type conversions in C#. Well, if we put everything in perspective, we have seen that after a variable is declared, it cannot be declared again. Or we cannot simply assign a value to another type unless that type is implicitly convertible to that variable's type. What does this actually mean? We have seen this already beginning with lesson 3. It means that if we declare a variable of type integer, so int I equals, if we try to put a string in there like hello world, it won't simply work because the string is not directly convertible to an integer. So this means in a certain way that if we declare a variable as integer, that we will have also to make sure that what we put inside that variable is really an integer. And also if we declare a variable of type string, that then we have to make sure that what we put in there is really a string. And this is also the same for our custom type, so for our custom classes that we might create. Let's imagine we create a class car. Well, if we create a new variable of type car, then we would have also to make sure that we assign a car to it and not a simple integer or something else. So this is really some basic C# programming that we've been already through. And this is the context that we have to keep in our mind when we think about type conversions. And why we talk about type conversions is because sometimes we might need to copy a value into a variable or method that is of another type. For instance, you might have an integer variable that you need to pass to a method whose parameter is typed as a double. And it could be, or there could be cases in which this might occur. Or for instance, you might need to pass an integer to a method that would normally accept as a parameter a long. And this is a really very familiar scenario. So in these cases, what we have to do is the so-called type conversion. So in C#, these kinds of operations, when we try to kind of convert a certain type to another type, is called a type conversion. In C#, we can perform basically 4 different types of conversions. The first one is implicit conversion. And for this type of conversion, no special syntax is required at all, because the conversion is type safe and no data will be lost. And here we can include as example when we want to pass from a smaller number to a larger number. And we can imagine here, for instance, that we have an integer I, which is as value 1 to 3, and we also have another variable of type long, which would be, let's say, variable k. And we want to assign the integer to the long. Now, if we remember correctly, when we talked a little bit about data types, when we talk about integer, what does this actually mean? As we said, when we declare a data type, we basically instruct C# or .NET that, hey, we want to have a variable of this type, so please allocate enough memory for me to be able to hold this type of variable. Now, integer, as we also discussed, usually is on 32 bits. So this means that every time we declare a variable of type integer, .NET will know to put aside in memory for us 32 bits to store a value. However, of course, there is a limited amount of values that we can store in 32 bits. And in this case, it's the integer max value, which is 2 billion and something. Now, the idea is, what if, for instance, our variable k, which is of type long, needs to hold numbers greater than 32 bits, or a value that needs more than 32 bits, let's say, to be expressed as value and understood by the computer. So in this case, what we could do, we could simply cast it to a long. A long in C# is, of course, a 64 bits integer. And what does this mean? It means that if we take a value that can, let's say, take at most 32 bits and put it, let's say, in a memory block that is 64 bits long, it's clear that we will not lose any type of information in there. So in this case, we can perform an implicit conversion. And in fact, we do not even perform it because C# and .NET does this conversion for us. We have only to know that we can simply cast an integer to a long without any other ceremonies. The second type of conversion is the explicit conversion, and this type of conversion is also called casts, and this is what you will see very often. Now, explicit conversions require a cast operator, which is this parenthesis, and inside the parenthesis we put then the data type to which we want to cast something. Casting is required when, for instance, information might be lost during the conversion, or when the conversion might not succeed for other reasons. And here a typical example would be some type of numeric conversions from a type that has less precision, let's say, to a type that has more precision. And here we can give once again, let's say, the example of an integer. We know that an integer we can store only whole numbers. Now, whole numbers are really cool, but if we think about precision, they are not really precise. And for precision numbers, we have what we call decimals or doubles, which basically also include let's say, fractions of the number. So it could be 0.52341, or it could be 10.12345, and so on. And if we want to cast this type of double or decimal to an integer, it's clear that the integer cannot hold that entire value with that precision, because an integer can hold only whole numbers. So when we cast a double or decimal to an integer, everything that comes after the dot will be lost during the conversion. So in this case, we can perform this explicit cast, it will work. However, we as developers, we need to be aware that during this conversion, there might be some data loss, because the number that we have as an integer after the conversion is really not exactly the same as the number that we had previously as a decimal or as a double. Then we have another type, which is a user-defined conversions. And user-defined conversions are performed by special methods that you can define to enable explicit and implicit conversions between custom types. These are already some pretty advanced topics, and we really won't cover them during this training session. And also we can make conversions using helper classes, and we already have a lot of helper classes in the .NET a runtime, for instance, system.datetime, and then we have a system bit converter, or we have the system convert, and so on. So we can really use them to perform this type of conversions. However, in this specific lesson, we'll only concentrate on implicit conversions and explicit conversions, because these are really the two types of conversions that are really important for us to know right now. Implicit conversions, as said, are for built-in numeric type. An implicit conversion can be made when the value to be stored can fit into the variable without being truncated or rounded off. And here we gave the example with the integer, which is stored on 32 bits, and the long, which is stored on 64 bits. And here there is really no data loss, nothing is rounded, so the exact same number that we had previously as integer, we can have after the conversion as long, so nothing special there. Now, in case of the explicit type conversions, if conversions cannot be made without the risk of losing information, then the compiler requires that you perform an explicit conversion, and this type of conversion is called a cast. And a cast is a way of explicitly informing the compiler that you really intend to make the conversion and that you are fully aware that data loss might occur. So this is a really important thing, and just remember here the example that we gave earlier when we want to cast a double to an integer, where we will basically lose everything that comes after the point in the double. And to perform a cast, we have to specify the type that you are casting to in a parenthesis in front of the value or variable to be converted, as we have seen earlier. And here is an example, a code snippet with an explicit type conversion. And we have that static void main method, and we have this double x, which is 1234.7, and then we have an integer a. When we cast x to a, what we will get afterwards will be only 1, 2, 3, 4. So what comes after the point, in this case the 7, will be totally lost. So in this case we can really see that there is also a data loss, and we as developers might need to be aware of that. For instance, it could be that at a certain point you have as a double something like 10.0. And this means that when you cast the double to an integer, you won't have any data loss, because after point there is only a 0, so there isn't really a value in there. Now, I think it's enough for the theory for this lesson, so let's now switch back to Visual Studio and try to write some boxing, unboxing operations and type conversions on our own. So we're back in Visual Studio right now in our My First App solution and project. You probably have it called My First App. In my case it's My First App 10 because I had a lot of first apps, so this is already the 10th one. What we want to do right now is to demonstrate also in Visual Studio and writing our own code how this boxing, unboxing and type conversions work. I have deleted everything that we had previously from the last lesson. I kept only this console read line because we want to keep our console open after we display something in the console. Let's get then started. The first thing, let's do some boxing, and we can also use a comment here, boxing. Here we see that we have an integer I equals 1 to 3, and then we want to box this integer, and we want to box it to a reference type. In this case we'll use object, which is a reference type in C#. And object, it would be called O, and this would be equal I. So in this case, when we do a console write line, what I would expect is that when we print O to the console, we should see this value 1, 2, 3. And this is exactly the unboxing process. Let's run the application and see if it is really true. So here we have it, we have 1, 2, 3 as expected. The only thing is that this 1, 2, 3 right now is an object, so therefore a reference type. It's not a value type anymore. Right now what we can do further is to unbox this object once again. And let's put also a comment here, unboxing, because this is exactly what we're gonna do right now. Here we can simply declare a new variable which is j, and this variable equals, here we have to unbox it, so we have to use also the parentheses, and we want to unbox it as an integer, and we put O, which is our object. So in this case we perform the exact reverse process in comparison to what we did earlier. So when we right now print this to the console, I would expect to have the exact value. The only difference is that we know exactly that in this case this is a value type, so it resides basically on the stack, while previously it was a reference type, so the value was brought to us from the heap. So let's run this program right now and to see if we have the exact same result. Indeed, this is the case. We have 1 2 3 and 1 2 3, which is fairly cool. So that's basically it. It's nothing very spectacular, boxing and unboxing. However, I want to show you one other thing that is important, and that also it can also act as an example on why I think that, at least for the beginning stages of our C# development careers, it is not really important to know exactly how boxing and unboxing works, because really we don't use it daily. And let's print something to the console. So we have a console.writeLine. In this case, I want to do the following thing. In .NET, we have this class existing already in .NET, which is string. And this class has already a lot of methods on it. One of them is called concat. And this concat method, what it basically does, as also the name does suggest, is that, well, you can provide here some type of things. Let's call them things for now. We'll see in just a minute why we prefer to call them things right now. And then it will concatenate those things to a single string. What we can put here is first one hello, then let's put 1 2 3, and let's also put true. What we notice here, that these things that we provide to this concat method, first hello is a string. It's clear because it's quoted. Then the second parameter is an integer because it's 1 2 3. And the third one is true, so it means that it is of type boolean. If we press F12 on concat and go to the definition to see exactly what we have used right now, we see that this concat method takes an object, which is the argument 0, because it is 0 indexed. It is the first argument that we provide. Then we have another object, which is arg1, and another object, which is arg2. But we see here that we have a string, an integer, and a bool. So what C# will do for us, it will perform the boxing process for us. So it will box this integer to an object, and it will box this bool to an object. And then it will concatenate, of course, these objects, and it will display them as a string. Let's run the application one more time, and I would expect hello 1 2 3 true. Indeed, this is the case. This is exactly what we have received here. So this is a really clear example for a scenario where we provide an integer and the compiler C# does the boxing process for us, and then it displays the concatenated string on the console. So as you see, there is a lot of boxing and unboxing going on under the scenes in C#, but we really do not need to perform these boxing processes every time manually, because this is cool. In .NET we have a lot of things that other developers have built at Microsoft, of course, and we can simply leverage the work that they have done and simply use what they have already created, and to make, of course, our life much easier. The next step would be to go to conversions, to type conversions, because that's really everything that we need to know right now about boxing and unboxing. Let's start with an implicit conversion. Remember, we said that we can perform an implicit conversion without any specific syntax. The C# compiler will know how to do this for us in scenarios where there is no data loss. And remember the example that we gave with the integer and the long. Let's have an int called a. This int would be once again equal 1 to 3. Let's make it 4, 5, 6 this time. And we also have a long. We can call it b. And this would be equal to a. So everything is okay, and we can simply console write line. So print this to the console, and it will print the value. Only that what happens behind the scenes is there is an implicit conversion. Because we have here an integer, which is a 30-bit value, we have here then on the other side a long, which is a 64-bit value. Of course, one 32-bit value, let's say, can be encapsulated in a 64-bit value. So in this case, there won't be any data loss. Right now, if we go and run this application, we see that we can print this to the console, so it's nothing really spectacular. The next step, of course, would be to perform an explicit conversion. Let's also type it correctly, explicit conversion. That should do it for now. Here we said that we can perform an explicit conversion, we can instruct the compiler to perform this type of conversion, but we have to be aware that there might be scenarios where we might lose some data. We can have here this integer c, which is 10.45. What we want to do here is, of course this cannot be an integer, sorry, this would be a double, because integers can only be whole numbers. And what we have right now is another integer, which is d. This integer would be equal c. Of course, we cannot perform this right away. And in fact, we have this red squiggly line here, and when we hover the mouse over it, it says cannot implicitly convert type double to int. And an explicit conversion exists. So are you missing a cast? And indeed, in this case, the message that we receive here is really important because we are missing an explicit cast and we want to cast this double to an integer. Right now, if we print this to the console, so we do a console write line, what we want to print to the console is, of course, d. Right now, what I would expect is that in our console would be displayed only 10, but not 10.45, which means, indeed this is also the case, but this means, of course, that some part of the value got lost. So this 0.45 got lost and we got only 10. Let's try another thing. For instance, if we have 10.60, or let's take it 10.65. What would happen in this case? Let's run the program and see. We see that it still displays 10. So this is important to notice that in this case, when we perform this type of cast from double to integer, so we cast a double to an integer, the value is not rounded at all. So we basically only take the whole part of the number and we simply dismiss everything else that comes after that point. So in this case, we lost 0.65, which of course in some circumstances might be a big problem. But if we would have a double like 10.00 instead, if you run the application, our integer, or what we would get to the console, is also 10. In this case, of course, we performed the exact same cast. We casted a double to an integer, but since we did not have a real value after the point, after the dot, then basically here nothing is lost. So it's important to note here, do not cast double to integers as a way to round numbers. There are other ways to achieve this in C# and we will talk about them at a later stage on this course. Once again, this is how a real explicit conversion works. And that's mostly it for this type of course. What we have seen here is what boxing means, what unboxing means, and how types conversions are performed. Maybe before we really wrap this up, there is only one more important thing to notice. When we talked about boxing and unboxing, we always made a reference to these concepts of value types and reference types. So boxing was the process, let's say, of transforming a value type to a reference type. And then unboxing was the exact reverse. So we had the reference types and we transformed the value from the reference type to a value type. So boxing and unboxing are always bound to this type of conversion from value type to reference type. Type conversions here, so implicit conversions and explicit conversions, are made also on same types. And we can even see here that integer is a value type and long is also a value type. So an implicit conversion occurs here even if we have the same type of values, so value types. And here we have double and integer, they also both are value types. So once again we can perform an explicit conversion also in case where we have variables that are both value types or both reference types. So it's important to notice this really small difference that boxing and unboxing always refer to the conversions from a value type to a reference type or vice versa, while type conversions like implicit conversions and explicit conversions are really not dependent on this conversion from value type to reference type. We can use type conversions even to make conversions from a value type to another value type. So once again, that's it for today. We've learned about boxing, unboxing and type conversions. Type conversions will be useful because we will use them fairly often. And boxing and unboxing are some topics that are really very popular when you attend interviews for a software developer job, especially for junior software developer roles. So it's important that you, however, know just a little bit about how boxing and unboxing works and what it basically does. So it's not really very spectacular. Thank you very much for watching this lesson, and I hope you enjoyed it, and I hope that you will be back during the next lesson where we'll talk about a way more interesting topic, which is inheritance in classes and access modifiers. So I count on you to be there. Till the next time, I really wish you the very best.